Alright, hello everybody. Welcome back. Thought I'd run through one more example of maybe how to lay out your amp. I apologize if the camera is too close to this. I haven't figured out how to raise the camera up to get it farther away yet, but once I get the top off of this amp, I think it'll look a little better. This is a rig I built this summer, and as a prototype. I had never, in all the years I've been building amps, I had never yet worked with the little 4-125s, and they've always intrigued me, and I thought, well, I'd like to see just what they'll put out. Well, this amp works. I'm not happy with the output. I get 500 watts out with a 5-watt drive. I've got a Cobra 138 XLR stock radio, and I get 500 watts out, about 600 on sideband. Not beautiful. I think I can get more out of it if I change and maybe convert this over to 4CX250s. That's my thinking. But I thought what I could do, since this was built already, this will give you an idea of a homebrew chassis. This is that same idea that I described in the last video about using aluminum angle and flat sheet stock cut down to size, and then you use the angles to mount everything together. This one has 090 front panel, an 090 rear panel, and 90 thousandths chassis, and it uses the same 1x3 L angle for the chassis bottom rails. I want to pull all the side covers off here and open it up and let you see it. What you can see right now in the view is the high voltage capacitor bank. You can see the diode stack, the modified microwave oven transformer is the black little box sitting over to the upper left. Get all these screws out of here. Built this thing like a Sherman tank. Okay, that's exposed. Now this side. Open it all up. Well, I was talking about layout. I had mentioned that you need to keep all of your bias, your control circuitry wiring, the screen supply, all of that should be under the chassis and away from the RF. And this will keep you from having problems with parasitic oscillations. You don't want the RF to get down in the underside of the deck. And this is just kind of an example of how you would try to lay out your amp. I've seen people, a couple builders I've got pictures from, and it appeared, from what I can see, that they tried to build it inside of what looked like a tower computer cabinet, which is okay, but none of the RF was enclosed. Everything was out in the open. I don't know that they ever got them running, but I would expect they would have had a lot of problems in trying to keep everything, you know, tamed down. I imagine they would have had a lot of oscillations. Okay, so like I said, what we can see, the parasitic chokes right here, the antenna key relay and the antenna connector right there. The little coax here goes down underneath to the input circuit. Lay it up on its side. You can see this part of it. This is plate choke and the DC cap to ground at the bottom of the RF choke. This is the plate blocking cap over to the plate tune and load. All real simple stuff. And now we'll flip it on over here. Get the bottom off of it. This might help you kind of get an idea as to how to set stuff up on yours. You got to find room where to put everything, and this may help. And I think later on, like I said, I think I will probably convert this. It'll be real easy to convert it because there isn't much difference between this amp and a 4CX250 amp. Keying circuit's the same. Screen voltage is real close to the same. Okay, now all the fans are off. Covers are off. Now we can get a look at it. Okay, the keying circuit is a little different. Roll the camera here just a little. You can get it in. Alright. Here's another control relay. This one deals with controlling the switching the radio into the either antenna or the input circuit, and this also is a screen relay or control relay. And on this amp I've built in a thing that I call Downstream Amp Keying. BBI made a good point, and we was talking about hot switching was the problem, and the reason why you don't want to do an auto key on a big amp. And it makes a lot of sense. He talks about using a foot pedal. Well, yeah, a foot pedal's okay, but what if you just built the driver with a built-in downstream keying relay that would key the big amp's antenna relay first, or at about the same time that the driver amp keys, and the screen supply is still delayed, so there's no RF going down the coax until the screen relay connects. And that's what I've done here. This little tiny relay right here coming off of the radio contactor relay. This green wire goes to the back, and that's an RCA jack. And that RCA jack is where you would plug your keying. Like, say for instance, you wanted to key up an SB220. This would do it. You hook a jumper with a RCA jack on each end. One end would go into the keying jack of the SB220, and the other end would go in here, and this rig would then key the SB220 without having to worry about a foot pedal in the mix. Just makes things a lot simpler, and it, again, it prevents hot switching. Alright, on here, these little resistor stack right here, this is my input swamp. I've got a little bit different tuning network on this one. I've kind of been experimenting with this a little bit. Let me see if I can just tip this to where I can get it, where you can kind of see what's going on. Now if I can just find something to prop it up with. Yeah, no, maybe. Maybe. Alright. Okay. Right here's the trimmer. I hope this is coming in the camera. This is just a one trimmer on this one. Instead of a pie, it's just a single trimmer. And this is a 4-turn coil. One end is grounded. One end of the coil is actually grounded to the chassis, and the radio input comes in at about 1 turn, and it's tapped at 1 turn. And what you have to do is you will play with the trimmer and the position of that tap on either more or less than 1 turn, and you adjust that with an SWR meter. And the same method, you would preload it with the swamp resistor, because that's what you're trying to match to. The tubes won't present any kind of an impedance because you're not driving the grids into the positive region. So all the radio needs to look at is the swamping resistor. And it's simpler, and I don't have to put 2 expensive trimmers in. And it works in this one, it's absolute flat match. And I always try to tune everything up to the middle of the band. Channel 20 is where I set stuff up. And so you can go all the way up to 40 and all the way down to 1. And there's very little difference in the SWR. Works pretty good. Okay, the other stuff here is, this is part of the grid swamping. I've got, there's 4K ohm of resistance here, and that provides about a 10 milliamp bleed, so you don't need any bias regulation. 10 mils is plenty to hold it stable. The other part, get up here where I can get into, okay, you got your stack of resistors right here. This is your power stages. You can, there. All those are stages of output, from low, next one, medium, and high. And then I've got a switch where I can choose between the high part of that stack or low. So I've actually got 6 different stages that I can, I've got 3 or 4 positions of low and 4 positions of high, I guess is what I ended up getting. Okay, on this one, I don't have a sideband delay switch. I've ended up putting just a pot connect to a capacitor, and then I can adjust the amount of delay that I'm just playing with that. Normally you just have a switch, but I thought, well, I'll try something different on this one just to see if it works. It seems to do okay. Some people like a longer delay, and this idea is, at least if you wanted to incorporate it, it seems to work pretty good. Okay, going on here. This one, you're looking at the bottom of the 2 sockets for the 4-125s. Now here's something I'm not happy with. These are ceramic sockets that are clones of the Johnson sockets. They come from China. They are absolute junk. The pin clips are misaligned. The holes, the distance between the rivet hole and the pin hole is correct, but they didn't hold the tolerance on the pin clips. The pin clips are so far in that the pin of the tube forces them open. And I sat and luckily I had the unit upside down when I first turned it on. I was just checking voltages. The filament pins showed a little bit of like a spark every now and then to my amazement, the pin just started turning, or the clip just started turning black, because there was resistance between the clip material and the actual pin of the tube. Well, that would have destroyed the tube had I not caught that. So what I had to do here, just to test it out and get it going, I had to clean the tips of the tube pins and solder a little jumper from the filament pin itself back to the other end of the clip. And this is another reason why I want to get rid of these sockets, and I'll just put a 4CX250 on a little copper plate, and I'll replace those 2 with 4CX250s. Okay, over here is a voltage doubler for bias, and I've got one for the keying supply, and then for the screen. And this is another one for the, it's the final, it's one more resistor and electrolytics here for the screen supply. They just kind of filter the last little bit of it. Probably didn't need it, but I just put it in on this one. I think I had about an extra 70 volts or so that I was a little bit too hot for the tubes because of the transformer I was using. So I just dropped it one more stage with a resistor, got it down to the voltage for the 4-125s. And that's about it. Screen relays right here. And it ties off, this little orange wire runs all the way over here, and it's controlled by the radio control relay. For where the radio comes in, this is the keying circuit. This is your sideband capacitor. Not sure if you can see that in the photo, but it's pretty much the same circuit as in the schematic that I give out in the sets of schematics. The only difference here is I think I got maybe a couple more relays in here. This one has the addition of the Downstream Amp Keying relay, and of course the relay for the screen is separate, just like in the schematics, and it's hooked up pretty much the same way. One side of the relay goes to the screen supply direct, and the output of that relay goes over to the stack of dropping resistors that in turn set up your output stages or output levels, so you can choose how much output you want. It's not really dial-a-watt, but that's the idea. You have stages of positions that you can adjust the power up and down without having to change your drive. And here, this is the filament transformer, but that's going to be coming out. I think this transformer will handle the 4CX250Bs, and it has a 6 volt output, and I'll use that. I think there's anything else in here that's not much different from the schematic, like I say. A couple little extra tricks that's in here, but you can add that to any amp. But the idea is, at least this is the size you could put a 4CX250 amp in, and it would fit quite nice. Let's see, what do we got? It's about 9 3/4 wide, just 12 inches long, and the cabinet from the base to the top is 10 inches. So yeah, basically a 10 by 10 by 12, and everything fits. Plenty of room. That may help you figure out your layout and what you want to do. Just kind of give you an example of what's possible. And again, this cabinet probably cost me, I don't know, I'd say I got less than $20 in it, somewhere around there. Okay, let's see, there's something else. Oh, I want to cover some parts. I forgot to mention that last time. Okay, let me grab this and set it to the side. All right. Okay, on eBay, well, I gotta zoom in so you can see this. Come on, a little more. I hope that's in focus. Okay, these are manufactured by several companies. One of them is Electromotive. One of them is Arco. This one here happens to be made by Electromotive. Anyhow, Electromotive, Arco, and Elmenco. They're what's referred to as a pinch trimmer. They've got a little screw with threads, and as you tighten it or loosen it, this screw on the back pinches together these little plates. There's a mica washer in between each plate, so that's how they're separated. Now, even if these aren't the right value, if you can find several of them in a pack, looky here, you can take them apart. If you get a capacitance meter, you can play with these things and refit them and make just exactly what you want, because you can take plates out of another one. Okay, there's the first plate. Now I've got several micas in here because I wanted a real low capacitance. And here's the other plate. And I think this one was about a 20 picofarad cap. And these little mica washers, normally there's just one. We can't even see it if I can get the light to shine on it. They're so, there we go. Whoop. Okay, there. All right. You just lay them over like you just start with one, and they're cupped too, by the way. They're a little bit bent to them. So you lay that in there, lay one or two of these, however you want to do it. Depends on what the capacitance range you want. And then the next plate, you just lay the opposite direction. And if you had another one, like more plates, lay in a couple more micas, just a sandwich, and then you lay the next one on. When you're done, there's a mica washer on the screw that keeps it from contacting anything. And it just simply goes in there, screws together. You get that all tightened down, put your cap meter across it and check and see if you got the right range. You can keep playing with that until you get the right amount of picofarads capacitance that you want. Now, the thing to look for before you buy these, make sure that you see this right here in the picture, this little brass nut. These things are basically almost unobtainium. So if the little cap doesn't have that on it, shy away unless you see if there's several of them and maybe the rest of them have their ring nuts, or maybe some of them missing. But choose wisely when you're looking at the pictures to look closely to see if these little nuts are in place. I've tried a couple different supply centers locally in town. I cannot find a thread brass nut that will fit this. I don't know what the thread is. I need to go to a machine shop and see if they can have a thread gauge that's more than just what I've got, because this doesn't fit anything standard. But I assume it's going to be some kind of a standard brass thread. But anyhow, make sure it's got that little ring nut. They're trying to get like about $12 a piece for these. And I think I saw on eBay somebody had 4 of them or 3 of them in a pack for like $15, free shipping. That wouldn't be that bad of a deal. Okay, see my battery indicator's getting close. I better close this real quick. A couple people have asked me about if I had a Patreon. I don't think I have enough content to open Patreon account. So the best I can do, if you feel like you want to make a donation, I appreciate it. I'm not asking for it. But it's this one here, Honda-CB350 at live.com. That's my PayPal. Email address, radiomedic111 at yahoo.com. Yeah, I just don't think I've got enough videos to put up that I'll ever make any kind of income from YouTube. I try, but it just doesn't seem to have a whole lot of viewers. So at least if you feel like you want to contribute, why, it would be much appreciated, and I will put it towards maybe the next video. They got some tubes I'd like to get and maybe make some videos on making amps with them. So thank you for next time, and we'll start putting something together in the next video. Thank you for watching. Please hit the like button, and we'll see you in the next video. Thank you. Bye now.